These are the latest Netcraft stats as of about mid-2015, and they show over the past couple of decades how the web server landscape has changed. Now clearly in recent years it's all been Apache and Microsoft's IIS. We've also seen Nginx gaining market share since about 2008, and a raft of other smaller ones making up the remainder of the web server footprint on the internet today. Now the reason I'm showing you this is to illustrate that there is some degree of variation in the number of servers out there. And when we start talking about risks in servers, there are unique risks to the individual web server implementations. There are risks that you'll find in Apache that you won't find in IIS, and vice versa of course. And the same goes for all those other servers as well. We're going to mostly look at common patterns of risks throughout this course, although we will delve into more specifics, particularly around IIS, simply as a way of demonstrating how web servers can be at risk. Certainly there will be comparable examples for other brands of web servers as well, but this will give you a good idea of the sort of things that you should be looking for. Now I want to give you a bit of an example of just how much goes into making a web server function. So let's go and take a look at how IIS does request processing. Let's talk through the HTTP request processing in IIS. Now I don't want to focus specifically on IIS in this course. It's more to give you an indication of just how much is going on in a modern day web server. So for example, when we look at the way a client makes a request for a resource, as that request comes into IIS via the internet, it hits the HTTP protocol stack. Now this is running in kernel mode, so all requests share a single virtual address space. So in other words, that kernel mode driver is not isolated from other drivers on the operating system itself. But once it's been intercepted by HTTP sys, it contacts the Windows activation service running inside SVC host. Now this is in user mode, so now we've got individual applications, which normally equates to individual websites, logically isolated from each other. And as I said earlier on, we'll talk about sandboxing more later on in this course. Now the activation service then requests configuration information from the configuration store. So this is in application-host.config. The www service then receives that configuration information, and this includes things like the application pool and site configuration. That service, the www service, can then use that configuration information to configure HTTP sys, which then allows the Windows activation service to start a worker process for the application pool to which the request was made. Now this application pool provides the isolation via this W3WP-exe process. So again, each application tends to have its own app pool which sandboxes it from the others. The worker process within there can then process the request and return it as a response to HTTP sys, which eventually means that the client can receive that response over the internet. Now again, this is a very specific IIS implementation, but it's worthwhile seeing how one of the major web servers on the internet today operates, particularly when it comes to isolation of processes. So hopefully that gives you a bit of a sense that there is actually quite a lot going on inside a web server when it processes a request. Let's now move on and have a look at the difference between web servers and web applications. And it probably sounds fairly obvious, but let's go and define it now, so that as we move forward through this course, it becomes very clear when we're talking about hacking the server versus when we're talking about hacking the application.